Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. We've now worked through all three types of interaction: dummy times dummy, dummy times continuous, and continuous times continuous variables. Now let's stick back and consolidate all the information about these three different cases. And the key question is, how do you actually interpret coefficients in interaction models? Think of this video as like the checklist you'll come back to every time you see an interaction term, because everything is going to be consolidated here. The general rule is start from the general model, meaning you have a model that will look y equals to beta 0 plus beta 1x plus beta 2z, and then ultimately beta 3 x times z plus an error term, okay? So the most important thing to remember is beta 1 is not the effect of x. It is the effect of x only when z is equal to 0, okay? And the same will apply for beta 2. Beta 2 is the effect of z only when x is equal to 0, okay? Now, this thing catches a lot of the students out in general. Even when I was a student, that was a little bit difficult to understand at the beginning, because in a standard regression, when I'm looking at the beta 1 is just a marginal effect of x, full stop. Now, with an interaction, unfortunately, that no longer keeps being true. So you might want to be very careful here on by looking at what your actual model is, so that you can then take that decision. Oh, do I stop with beta 1 as the marginal effect of x? Or now do I need to think differently because I have an interaction? Now, the second step from your general model, so think of it next step, would be writing the marginal effect. So for marginal effects, it's very clear that you have to do the partial derivative. So you have delta y with respect to delta x, for instance, it's going to be beta 1 plus beta 3z, okay? Now, very clearly in this interaction model, we have that the effect of x depends on z. So you cannot summarize it, unfortunately, with a single number anymore. Now, what is the core principle that you have to keep in mind? The core principle based on this thought process would be that you have to evaluate the marginal effects at specific values of z. Okay, this is the key habit you need to build. So don't report beta 1 alone, but report beta 1 plus beta 3z at meaningful values of z. And if your question is, well, what are common choices if I need to present these like at meaningful values of z? This will depend a little bit on context, but most of the times students always jump into, well, let's check it when z is equal to 0. And you can also have cases, well, let's check it when z is the mean of z. Or you can check, when Z is one standard deviation above mean. But otherwise, as I said again, it will have to be on context depending on what kind of variables you have and what do these values of the Z mean for the variable that you have. In any case, you always need to state the value which you have used. And then the next obvious step would be, now that you know all of the numbers that you need to apply all of them across the cases that you have. So finally, apply the numbers. So in the case of the dummy and continuous case, so dummy times continuous case, what will happen is that your partial derivative, delta y, with respect to delta x is going to be beta 1 plus beta 3 d. Okay, assuming here that x is your continuous variable and then the z is this d variable, which is a dummy. In this particular case, you will have two subcases to look into, in which case is if d is equal to 0 and if d is equal to 1. If d is equal to 0, then the effect is just beta 1. However, if d is equal to 1, your effect will be beta 1 plus beta 3. Okay? In the case of continuous times continuous case, you will have, again, that delta y over delta x is equal to beta 1 plus beta 3z, because now we keep the z as continuous, no longer as a dummy. So in this case, your effect depends on the value of x. Oh, z, sorry. And ultimately, you will need to report results at meaningful values, okay? Or of meaningful values. In the last case, the dummy times dummy case, we have that now the effect is going to be beta 1 plus beta 3 dummy again, okay? And keep in mind the derivative here would have been delta y with respect to the other dummy, okay? So D1 and D2. Again, you'll have to look into cases. The case is if D2 is now equal to 0 or D2 is equal to 1. In the first one, the effect is just going to be beta 1, but in the second one, effect is going to be beta 1 plus beta 3. Okay, so same formula in every case. The only difference is the range of values z or d can take. Now, never interpret, and I'm going to put this as a key warning in here, never interpret beta 1 in isolation. When there's an interaction term. Okay, so beta 1 is a partial effect. It only tells you partial effect. It only tells you the effect of x when Z equals 0. And if Z is equal to 0, is not a meaningful value in your data, beta 1 alone is not a meaningful number, okay? Now, when you see an interaction term, follow these steps as a summary. Write out the marginal effect, choose meaningful values of Z, and then evaluate and interpret at those values. This three-step routine works for every interaction model that we see in all of these like different case scenarios in here. So from now on, instead of saying X increases Y by beta 1, you will have to say the effect of X on Y depends on Z. At Z equals to some value Z0, let's say, the effect is going to be beta 1 plus beta 3 Z0. This is the language of interaction models, and getting comfortable with it will make your like studies or finding the results and different exercises a lot more easier. Interaction models, remember, they describe heterogeneous effects, effects that vary across individuals or groups or contexts. And this is exactly what makes them so powerful and why careful interpretation matters. I hope that this video summary managed to put together all the information that you've seen in this mini arc of the interaction models. And with that being said, stay tuned for the next video because we're going to look at interaction in log models and common mistakes that students usually make when dealing with interaction models.